Hello everyone, welcome to S-Science. Today we're going to review a topic that we are all quite familiar with, and it is going to be that for electrostatics. Okay, so what exactly are electrostatics? Electrostatics is the study of electrical charges at rest, along with the electric fields and the potentials that they create. So where do these charges basically come from? They come from matter itself. So, as you recall from chemistry, we basically studied matter extensively, and we saw that really an atom, it is simply composed of a nucleus that houses the protons, the neutrons, and an electron cloud of electrons that will basically move around in orbitals within the atom. So in chemistry, we use relative charges for protons, neutrons, and electrons. So if you recall correctly, we said that protons are +1, neutrons are 0, and electrons are -1. That just simply means those are relative charges. It simply means that protons and electrons are exactly the same charge in numerically, but they are in opposite charges. And of course, neutrons have no charge. For physics, we will actually have to learn and know and remember where to find it, what the actual charges are. So for proton, we're going to use an elementary charge, which is going to be positive 1.6 times 10 to the negative 19 coulombs. Coulombs, of course, being the units, as you recall, by which we measure charges. Neutrons are going to be 0 coulombs, and electrons, of course, are going to be a negative elementary charge, which is going to be 1.6 times 10 to the negative 19 coulombs. In other words, we can no longer use relative charges for any problems, but we have to go to the actual charges. The same thing, of course, counts with the mass. So if you recall correctly, we simply defined arbitrarily as protons and neutrons as 1 AMU, atomic mass unit, and electrons as about 2,000 times smaller than an AMU. So now we are going to use the actual mass. And as you recall correctly, physics is always in units of MKS, and protons are now going to be as 1.6 times 10 to the negative 27 kilograms, neutrons 1.67 times 10 to the negative 27 kilograms, and electrons, of course, are going to be 9.11 times 10 to the negative 31 kilograms. So we can no longer use relative masses, but rather we have to use the actual masses. So where does that leave us? Okay, so what does that mean? Elementary charge, of course, is the charge that is present on an electron or a proton. Electrons, of course, going to be negative elementary charge, and a proton is going to be a positive elementary charge. So that means if we have one electron, the elementary charge is going to be negative 1.6 times 10 to the negative 19 coulombs. But if you have two electrons, it is going to be double the elementary charge, which is going to be negative 3.2 times 10 to the negative 11 coulombs. If you have three electrons, it is going to be triple the elementary charge, so it's going to be negative 4.8 times 10 to the negative 19 coulombs. You will never have a charge in between those two. It's either going to be 1.6, 3.2, or 4.8 times 10 to the negative 19 coulombs. You cannot have a 0.5, let's say, for example, of an electron. The same thing would be with the protons, with the only difference, of course, of it being positive. So that brings us to the formula. Q equals N times E. Q, of course, is the quantity of charge, N is the number of electrons, and E is the elementary charge of 1.6 times 10 to the negative 19 coulombs, as we have just discussed. In another video, I'm going to put a problem, and you guys will actually see how we can actually count either the number of electrons or the charge produced by a group of electrons. Now, that is, of course, the problem I'm going to pose in a different slide. But for right now, let's talk about charged objects. An object is charged if it gains or if it loses electrons. You cannot have movement of protons or neutrons. They're held together in the nucleus by the strong nuclear force, so they will never move. Protons and electrons are never mobile. So that means the object that will gain electrons, of course, is going to be negatively charged, and the object that loses electrons, it is going to be positively charged. So how do we charge an object? We have three ways by which we can actually charge an object. You can charge it by friction or pretty much any kind of addition of energy such as heat, light, so on and so forth. But mostly for physics, we're going to be looking at friction. We can charge an object by induction, and we can also charge an object by conduction. So what are these? So friction is basically applying a frictional force, okay, on electrons in order to cause them to move between objects. The characteristic example that we saw in class is, of course, fur and lucite rod. So when you rub together fur and lucite rod, we said that the lucite rod becomes negatively charged because electrons are transferred from the fur, making it, of course, positive, to the lucite rod, making it, of course, negative. And the opposite of that is, of course, silk and glass rod. When you rub those two together and you apply frictional forces onto the electrons, you cause them to move. So the glass rod becomes positively charged because electrons are transferred from the glass rod to the silk, and of course they make it negative. So bottom line, what you have to remember here is that lucite rod always becomes negative for any kind of problem, and glass rod always becomes positive.